college days, right? Okay, so my name is Hardik Mistry, and today I'm going to. Ideally, I want to do a workshop. So if you have Azure accounts, I want you to sign in to your Azure accounts if you have them. If you don't have them, it's okay. You can still follow with me because I will also do something similar to that. Okay. So in today's topic, what I'm going to cover is how you can or why you should build reliable services with Azure. Normally, as programmers, I'm assuming how many of you are programmers or developers? I mean, you might be a manager today, but you're still writing code or, telling your juniors what to do, what not to do, something like that. So the real emphasis is, by experience, what I've learned in the industry is that as a programmer, you are always required to write code. That's what academic things are. Write code in Python, Java, blah, 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 things like that, right? But nobody really tries to pay attention on making things reliable. What I mean by reliable is, many of you might have seen such incidents and episodes in the past where popular services such as Twitter, Netflix, etc., they are offline for a while, or you are not able to tweet, or you are not able to do something with that particular service. You might have experienced an incident with Flipkart when they announced the big billion day sales for the very first time. There was some glitch with ordering system and things like that. Things go wrong for a variety of reasons. It may be a developer's problem, it may be an infrastructure problem, right? So what we are going to talk about is how to build reliable services with Azure, or what are your options when you want to build a reliable service with Azure. So before we begin, some key challenges that we should cover, or how it should help you. So the challenges includes unavailability of the service. It also affects your customer retention, because let's be honest, you're not the only provider in the market. Let's say today, if you are buying a ticket from Book My Show, and if it's not a reliable experience multiple times, you will probably consider switching to an Inox or a PVR app itself, and vice versa, right? So things like that. So retention becomes difficult if your services are not reliable, and indirectly it affects your business, because less the customers, less the revenue, and hence, even if the idea is great, it does not convert into anything useful. Yeah. So just some basic background. So one of the key topics is HADR. You may have heard about it in the past. You might be implying those policies at your organization as well. So HADR stands for high availability and disaster recovery. These are two different paradigms, but they interlap. Hence, they are commonly referenced together most of the times. In today's talk or workshop, we are focusing on HA, high availability. We will not get into deep insights into disaster recovery options on Azure, because it's a different set of offerings and different ways of doing it. So why is it important, or what is it? So it's an architecture that it's a policy that you will apply at your organization to make sure that your services are always available. Now, why is it important? Again, more or less the same things. It helps you, or rather, if you imply it correctly or employ it correctly at your organization, it will make sure that your services are always available. It will make sure that your customers are happy, because lesser the complaints, lesser the support issues, overall the organization is satisfied, right? And obviously reducing the churn rate. Does anybody know what is churn rate? If you're from business, you might have studied about it.
Attrition.
What is attrition? You're just changing.
Losing customers to our competitors.
Yeah.
Customer leaving the service.
Yeah, right. So more or less retention, but again the churn rate. So the lower the churn rate, is it better or not better? The churn rate should be low, right? Again, it is important if you are into business, right? So you might have seen this popular meme in the internet, right? Now, this is a traditional issue with most of the startups. What happens is, let's even not just startup, I have seen it across enterprises as well most of the times. You might have worked with something called as pre-sales, salespeople, right? They're trying to offer a solution and sell something. So their motto is to sell it to anybody and everybody, right? And anything and everything, right? They try to sell you a pencil or this and that and everything, right? But once they sell it, and when you start using it, you might realize that instead of a pencil, they have sold you something else. Yeah, and that has happened with all of us in different formats across different industries. So it's not my problem. So once you reach out to them, they'll say it's not my problem. Reach out to tech support or something like that, right? So just to fast forward the overall philosophy, what you see here is a ideal architecture diagram when you are implementing some services. In this case, you will see some common words. If you are already using Azure, there is a service called Front Door, which we'll be talking about today in the demo. There are services for hosting your app. We call it a web app or an app service plan, and it's a combination of all these services together. What you importantly notice is there are two different regions. They are exact replica of each other. One is the primary, one is the secondary. I'm sure all of you have already seen it or used it or applied it in one way or another. Meaning if you're an app developer, maybe your role is only to take care of the app infrastructure. If you're a database person, your role is only to do the database side of things. It depends on your role, what you do, how you do it, right? So what we want to do is that, first of all, how will you decide if it's working correctly or not? So even though this is an older slide, the intent of this particular slide is to give you insights on something called as observability. You might have heard about that word in your company or somewhere in the blog, right? So, and you might have also heard a similar word called APM, application performance monitoring, right? Now there are a variety of tools in the market which lets you monitor how your app works and things like that. It helps both the developers and the ops teams, because developers can understand where it's failing more often. It could be a bug, it could be a dependency into a third-party SDK or a database call or variety of stuff. So it is important that you should monitor your infrastructure as well as services, right? So this is just some basic theory that it gives you some common insights on, hey, you should set up some alerts for monitoring, things like that. And I'll be doing a small demo just to give you a feel of what this is. So when it comes to offering resiliency, some of the common terms that comes across on your Azure platform is Azure Front Door, and there is another service called as Traffic Manager. You might have heard about that service as well. There are two services, right? So with Front Door, what happens is that if you're serving internet traffic, HTTP protocol traffic, Front Door is a go-to choice because it cannot cater to other protocols. But let's imagine you are, let's say, working on a mainframe system or a legacy system. Now, legacy as in it may not be as old as COBOL or Fortran or something like that, but it may or may not need HTTP for communication. It might rely on TCP or UDP protocols. In that case, you will have to use a service called Traffic Manager, right? So as of today, in today's demo, we'll be doing Front Door because my demo includes two apps and how they work together and things like that. There are, later on when I share the content, you will find some links in it and you can visit them and understand more, basically. So on this slide, what I'm talking about is how to set up the resiliency for the app service. So in this particular slide, what I'm talking about is setting up something called as auto scale for virtual machines. As of last week, Microsoft has made auto scale for app services also GA. Until last week, it was in a preview, public preview. But as of last week, it is now in GA for app service as well, including your virtual machines. This slide talks about how to do a SQL failover group. So if you are using SQL Server hosted on Azure, when you deploy a service or a resource, it is deployed only in a single region, right? But obviously, for a variety of reasons, the resource is not available. There could be a networking problem or a data center problem or whatsoever, right? In that case, you don't want your apps to go offline just because it's not able to read and write data, right? In that case, there is an option for you, and you can set up something called as a failover group, as they call it. It's a built-in feature of SQL Server hosted on Azure, meaning as a PaaS offering, not self-managed. So if you have a SQL Server running in a virtual machine, in that case, you will have to do some load balancing and this and that. But this is an offering if you are using SQL Server as a PaaS. So what I'm going to do is I'm going to do a demo and also walk you through. So what I want all of you to do is scan this QR code. It will take you to our website. Please do this if you are interested. So all of you are on a web page. Let me make it easy for all of you. Let me let me see. Okay, it's visible for all of you. Yeah. Okay. So what I am taking you to is it's an app, but it's accessing itself via this URL. So in case if it's not working for you from the QR code, you can use the text hackmum.azurefd.dat. I promise you it will be interesting. Please open it on your phone or your laptop if possible. If not, it's okay. Everybody is having a web page? Yes. So I will also do it along with you, right? So I'll visit the web page. So for me, the response is coming from East US. Is it the same for all of you? For some of you, it might also say West US. How many of you get response from West US? How many of you are getting it from East US? Okay, almost similar. Okay, now just to give you a background what this is, let me take you to my Azure portal. So what I've done is, for the sake of the demo, what I've done is I've set up nothing fancy. This is pure vanilla setup. So it's a very simple exercise here. So I have a simple app service. The app service is using a very basic tier of an app service plan. So for example, you can see that I'm using a B1 or a basic tier. And just for your understanding, it's a very small size machine. So if I, let's say, zoom out, let me zoom out a bit. And if I, let's say, select scale up, because that will allow me to show you the capacity of the plan. If it's not readable, just for your understanding, B1 offers me 1 core CPU and 1.75 GB RAM. It's a pretty small machine, nothing special about it, right? And I've selected a Windows as a machine, but the same applies with anything else. I mean, what I'm demonstrating it's technology agnostic, meaning you don't really have to do anything special with Windows versus Linux or even a Mac, right? So this is hosted itself into West US as a region. You can see near my selection. Something similar what I've done is, for the demo purpose, I've created a copy of it, but the only difference is between these two services is this guy is hosted in East US. So these are two different locations, two different regions geographically, right? Both of them are running a simple MVC application. The UI that you see is a very simple MVC application, nothing fancy. It's a simple text page, right? But importantly, both of them have two differentiators. One of the message says welcome from East US, one of the message says welcome from West US, right? So what we want to do is that, imagine, and maybe let me just, for the sake of demonstration, let me independently open each of the services. So what I'm doing is, I have, if you may be able to read my URL, it is East US, so that's why it says from East US. And if I repeat that from West US, just for your confidence and not so that I can prove that I'm not faking it, you can see that I have two apps running. Both of them are online. I'm running it in front of you, right? So what I'm doing is that this one is from the Azure front door. So I still get, let me rather do a incognito window. rather, let me. Okay. So it's a fresh browser window. So it's dynamically load balancing, as you can imagine, right? Now, what I've done is that with Azure Front Door, you can choose variety of different options. So just for your understanding, if I take you to the Front Door as a resource, so rather let me do this. Let me create a new Front Door for you, or in along with you. So with Azure, when you try to create a Azure Front Door service, you will get two different options, because Front Door combines two facilities. One is itself as a load balancer, and another is it also offers you the ability to set it up as a web application firewall, or WAF, right? Many of you may or may not be affected today, but in real world, with enterprises and corporations on the internet, security is a major threat, right, or a major concern. And Front Door allows you to easily set up a firewall. It also has built-in policies wherein you can set up bot policies. For example, it has some known attacking policies, so it will prevent or stop those requests to your service. So it will further enhance your ability to stay secure. But you may not want it, just because, hey, I don't want to create that. So for example, if I choose this as an option, explore other offerings, you still get an option to set up just the Front Door service, and that is under the classic option. Now, since I already created that, I'll just go back to the same resource I have, right? You can notice that I have an option to enable web application firewall if I want to. So if I click here, I can basically define some rules and policies. For example, there is a, you can notice that let me zoom in a bit. So you can probably see here, there is a small dash that indicates that this resource is currently not protected, and I can decide to add a policy or things like that. So if I say add a policy, I can go and add more policies and things like that. Probably we'll do a separate workshop on that. Now, importantly, what you see here is the Front Door designer, and there are some different layers of setup. One of them is the domain itself, how you want to access the service. That is the public facing URL, or FQDN, right? Fully qualified domain name. Then there is a backend pool. So for example, if I, just for your understanding, you will notice that I am having two resources. These are two app services. One of them, as you can see in the abbreviation, it says EUS, East US resource. One of them says WU, that means West US resource. And both of them have the same priority, right? And it also has the same weight. Now, what you see here is something, and that is part of my MVC app. So I can decide that how it should decide, because what it will do is it will run a probe. So every certain seconds, it will try and hit all the resources configured, and it will decide if it's online or not, right? So currently you will notice that it says, or it has the status as enabled, meaning both the resources are available at the moment, right? And what you can optionally decide is, if you are building a service which is not serving HTTPS traffic, you can choose to switch the protocol from HTTPS to HTTP. But it depends on what you want to do and things like that. Now here in the load balancing section, what we are trying to do is, sample size will basically decide that how many times it should compare. So for example, right now when the probe hits my services, it will compare data for the last 4 attempts and make a decision that if the resource is healthy or not, right? Depending upon your tolerance, I would say, you will decide if the number should be higher or lower, okay? In this case, I have left it to 4. This is the default one. I can also probably take it to 1, but as you can see, it will not let you do 1 because of the successful sample. So it will compare. So 4 versus 2, it's basically 50% chance, right? I hope you're able to make sense of these numbers, right? And latency sensitivity is, so when it says 0, of course, there is some description, and in my slides, there is some link as well, which will take you to a Microsoft Learn example wherein you can read more. So the idea here is that as soon as one of the resources is unhealthy, it should automatically take traffic to a failover resource or a secondary resource. So what I want to do is, of course, I can do some routing as well here. So here in the routing section, the good part of front door is optionally, if you are serving a application which involves caching on the front end, let's say it's an Angular application or a Node.js application, mostly you have some assets, right? So one of the benefits you also get is you can have built-in caching as well without implying or taking care of any extra CDN network. Behind the scenes, there is a CDN working, but you do have an option of caching. So if I say enabled, it can cache your request. So you can say how I want to cache. Do I want to cache with query strings or without? And there are some options. So I can say, okay, cache every unique URL. So every request that is hitting my resource will be cached, and accordingly the traffic will be served. This is useful, especially if it's a front-facing application, meaning mainly front end, basically. This setting may not apply for a backend system because you don't want to cache response for every request, right? Otherwise, you will end up losing updated data, right? So when you're setting these settings, make sure it is, make sure you know that if it's required or not. And here I can again decide how I want to do port protocol forwarding. So I'm saying match a request, meaning if it's coming from HTTP traffic, still it should work. If it's coming from HTTPS traffic, it should work. What I can also choose is I can do a redirect. Honestly, I do not have a very good example how this affects your availability, because no matter what setting I keep, what I'll be doing is I'll do a demo wherein I'll turn off one of the services to simulate that it is down, right? And I'll ask you to refresh your browser. So in that case, all of you should be able to get some content. So if I turn off West US, ideally within a second, all of you, when you refresh, you will get response from the East US or something like that, right? That's the aim, that the availability from a consumer point of view should not be interrupted, right? So for now, I'm just keeping it as forwarding. So it forwards it to the backend pool, right? And so this is a very simple scenario that I have currently set up for the front door. And what I'll do now is that I will, let's say, go back to my incognito or private window. Currently, you can see we are getting traffic from West US. If I refresh, and I've not done anything else, anything right now. So everything is still working. I can now go and turn off one of my resources. Let's say I can say turn off my East US resource, for example, or maybe because I'm getting requests from West US, let me just prove the point that it will work for me as well. So I'll go to the app service that I am interested in, and I'll simply say stop. So you can see that I have stopped the app. And if I copy the URL of the app itself and try to visit it, let's see that if it's available or not, right? It's still not. Okay, so as you can see that my service is not working now. However, if you are a consumer who are actually depending on this particular URL, the front door URL, you will see that it takes a while to catch up, but it automatically redirects the traffic. Now this happens because of the caching and all the other things that are there in the networking part. So yes, you cannot control everything. However, this is still better than losing your customers to an offline service, right? Because by the time you get a report that it's not working, you may or may not know the reason. And your SLA means service level agreement, you may or may not be able to get it up back, maybe even for a few hours, maybe for a few days, depends on the problems that you have, right? So using front door, what you can do is you can achieve a high availability of the app service. The same can be achieved via virtual machine as well. So for example, what you can do is, even if you have, let's say, 2 or multiple virtual machines, you can configure front door for the virtual machines as well. And additionally, if I just go back to my presentation, so, and sorry, I'm just speeding it up so that we can save some time and also, keep it less occupying for you guys, right? So what we are going to talk now is about load testing, or why it's important. So what we saw right now is how it's important for you to make sure that your services are available via services like front door, traffic manager, etc. But again, that is good enough to make sure that when a resource is offline, then you have a fallback system. So that covers that part. So it covers the infrastructure side of things. I hope you're able to understand, right? But as we are programmers, we do interesting stuff, mainly copying from Stack Overflow, right? And we are very good at it. That leads us to unknowns, mainly into our code, and that leads to a lot of hiccups with the app itself. What I'm trying to give an example is, normally I call that as a works on my PC problem. As a developer, let's say I'm assuming all of you might have at least built a backend system as a hobby or just to learn. A simple GET request from Postman, Fiddler or something, get a response, and you feel confident, king of the world. आज चल गया, धूम मच जाएगी. But what happens is the minute it goes to production, weekend में call आता है. वो भी Saturday को ही. Why? Because weekend में ज़्यादा traffic आता है. Yes or no? I'm just giving a hypothetical situation, but that really happens with all of us. Yes or no?
Yes.
Weekend में call आएगा. You'll get a call on weekend from your senior saying, oh, this is not working, that is not working. What happens is it starts with a problem from someone else, right? Someone else monitors, looks at what's the problem, where is the problem, etc. And mostly it's backend. Why? Because the team who is looking at the front end, normally they'll look at the app, because the customer's complaint is that the button is not working or the UI is not loading correctly, and so on. So that's where the problem originates. And by the time somebody investigates, it turns out that the backend response time is too slow. The request is taking 1000 milliseconds. They'll make up some situation and they'll call you. Hey, how come it's not working? What were you doing? And 10 other things will happen. So what can you do as a developer to prevent yourself into getting from such situations, right? So one of the key benefits is by doing load testing, right? Load testing is nothing but you can employ any number of tools. Today we are going to use Azure's own load testing service, but there are many tools in the market such as JMeter from Apache. Postman also offers something called as Runner. There is also a tool called Fiddler and things like that, right? So again, for a very simple demo, I'll try to prove you that how load testing can help you. So again, and just to give you a background, so this is the app service or the MVC app that I am using. Nothing special. It's a simple, let me just go here. So the home page literally prints a welcome message. Nothing fancy, no backend call, nothing external. It's just a simple app, very vanilla, nothing fancy, right? So what I'm trying to say here is that how can I check that my app will perform good enough or not under load? Why? Because these problems appear when it's under load, right? For example, when you are building a service, at best your load testing strategy involves you and your friend. You'll say, acha, click this, I'll click this, you click it 10 times, I'll click it. That's a jugaad we all go through, yes or no? And because people are smiling, I believe they are doing that also, right? But don't do that because you'll get a call on a Saturday when you're out with your loved ones on the weekend, right? So to avoid from that fiasco or situation, what you can do is try to be proactive by using something called as Azure load testing. So just for the sake of saving time, I already set up a service. It's a simple resource. You can just say create and it will create a load testing resource. So what you can do here is that you can do two things. One, you can simply give it a URL and it will attempt simulating load onto that URL, whichever you give. And another is you can also do something complex by creating a JMeter script. JMeter script is nothing but you can further specify some parameters. For example, you can dynamically pass random data. Let's say it's a create user service. So you might want to dynamically pass in different emails, different profile settings, etc. So in that case, you will have to depend on JMeter or something like that. But for today's demo, we'll be using a simple HTTP test. So what I'll do is, I did something yesterday just to make sure that it works. Yeah. So what I'll do is I'll create new because this is pretty fast to demo. So you can see here probably, let me zoom in. So you can see when I say create, I have two choices. One is with a URL or with a JMeter script. For the demo purpose, I'll go with the URL. Here I can give it a name. So let's say so I'll say before scaling. I'll just give it a title. It's just a tag. Okay. I'm saying, okay, run this load testing as soon as it is created. I don't want any advanced settings right now. I want to give it a URL. Now, if you may remember, we turned off one of the services. So let me just make sure that everything is normal. Rather, let me double check. So I'm on the East US service. And as you can see, it's still working, but I did not turn on the West US yet. So I'll just double check and it's not working, but that's fine. So what I'll do is, just for the sake of understanding, I'll just zoom out and I'll say I'll go to the East US service. I'll go to the East US app service plan. And just for the sake of understanding, because I am currently running it under the free plan does not offer scaling. Scaling is nothing but you want to improve your throughput of your compute, right? So the bare minimum you need to go to is basic tier. So as you can see, the bare minimum is B1. It gives us the best scale size of 3. So maximum I can have 3 instances, right? Which is good enough for the demo, for my proof of concept. And you can also do the same at your organization if you are also following similar setup. So what I'll do is I'll simply scale. I'll upgrade because I'm on a free plan. And upgrading takes maybe a minute more. Okay, so we are on a basic plan, right? Let me go back and click here and there just to, so it's a B1. You may not be able to read it, but now it says B1 instead of F1, right? So just to give you an idea that my instance count is 1. So you might be able to read here. It says instance count is 1. What I want to do now is, before I scale, I want to run the load testing just to see what my app does by default, right? So if I go here and put in the homepage URL, this is a homepage URL, right? Nothing special. So I just put that URL, nothing extra. You may or may not include query strings, if depends on your service, right? Now there are two different metrics by which you may want to do load testing. So there are two options. One is virtual users. So it will simulate number of users connecting. In simple words, it will simulate number of clients connecting to your URL. Other option is request per second, meaning it will basically, you want to make sure, let's say you have a goal that my system should be capable to serve, let's say, 1 million requests per second. I'm just giving a hypothetical scenario because in real world, you may want to achieve that SLA, right? So depending on your need, you may or may not want. So let me change the radio button here. So you will see that if I switch to request per second, I can give it some benchmark that how many requests per second it should try to fire out. But obviously, when the load testing runs, it will eventually tell us that what the performance was, right? For ease of understanding, let us stick to virtual users, right? By default, it says 50. I will want to simulate 1,000 users connecting to my web page in a duration of 2 minutes because we want to save time, because whatever duration I mention here, for that duration, it will run. I don't want to run for 20 minutes and look at the screen, right? So we'll say 2 minutes, okay? And ramp up time is 1 minute. So in case of this default URL based testing, the only limitation is that the simulation test is, it starts at for 1 entire minute. In this case, 1 entire minute, it will stay at, let's say, a number of users, maybe 50% users or things like that. And then it will ramp up to all the max capacity. In this case, my input is 1,000 users or virtual users, right? So what I'll do is, and again, by the way, this is not a free service, so don't use it lightly. It does come with a cost. So just a word of advice. So you might go home and click, and then you'll get some bill. Yeah. So as he mentioned, be careful with the cost. Yeah. So I'll just say review and create because I don't want to do anything else, right? You will notice that it automatically uses JMeter anyway, because that's the behind the scenes, that's what it is using. So I'll say click on create. So the test is created and it has also now started. So you will see that it will ramp up. and it will start, and in 2 minutes it will basically complete and give you some report at how many requests it is able to serve and things like that. नहीं आया.
Reliability wins. Which I hear. Sushmit's presentation was not in vain.
No problem.
Okay. Are you bringing a logical end or like
नहीं, maybe 10-15 minutes.
10-15 minutes? Okay. How many of you are doing the workshop?
नहीं है, Azure है सबके पास.
नहीं?
I asked them but nobody.
वो तो हुआ ही ना. Okay.
हाँ, पास नहीं है.
No, that means I need to complain about.
हाँ, वो मैग्नस को बोलेंगे.
Magnus ऊपर गया ना. This is second year now.
Okay. Let me refresh. So it has not started yet. So
configure auto scaling from to go from 1 to 3, or that's not.
So what I'm trying to simulate right now is what happens as a baseline. So my baseline is one instance. So we'll get some numbers. Then we'll scale to 2.
Okay.
And then we'll compare the numbers. And that is how you will be able to analyze. So it's mainly just a simulation for people to understand why it's important. Because I've most of the times wherever I'm being consulted, it's always about slow apps. And the very first thing I ask them is, do you have some reports? And the 100% times I'm getting answers, wo kya hota hai? Right? They know about it, but they do not have the energy to put in to, do it, and then they have no clue. They have some exceptions and logs. Sometimes it's threading problems, SQL Server problems, depends.
My ramp up time will be 1 minute. At for that 1 minute, it will scale up to 2. And in the next 1 minute, it will
1,000
it will
users.
using 2-3 instances maybe. Because,
So it depends on the load.
yeah, it
So-
might detect that.
Yeah. So I can demo that also, but the idea is that just to give a benchmark that even for a manual system, you don't really need to do auto scale. You may have some metrics. For example, let's say if you're an e-commerce website, depending upon your analytics, you can collect that in which time period traffic is more. So you can do manual scale or auto scale in terms of scheduling. So schedule scale can also be done. That will basically save cost, because auto scale you'll have to go all the way to premium tier. Premium tier is the most expensive service plan, which may not be necessary. You can easily come and click here, as an alternate. Okay. I have some numbers, but it's probably not. Yeah, never mind. It is still going on, by the way. Okay. It's not yet correct. These numbers are fluctuating. Yeah. Okay, never mind. Let's not spend too much time looking at this screen. What I have is that I also have a test run from yesterday, and just to give you a feel of it. So I did 2 tests, and I can now compare. This is from yesterday. It's a similar setup, nothing different, but I did it anyway in advance to save some time. So what you will see here is, if you see the graphs, the one on the left indicates number of requests or virtual users. So it says 1,000 in both the runs. So the one with the blue is where, as you can imagine, it is with one scale. How can I say that? Is because the response time is significantly higher. So every request is taking almost 30 seconds to serve. Whereas if I scale it to 2, meaning just improving by double the capacity, I'm getting improvements by 18 seconds. So it's basically less than half almost, right? Also, an important metric, it's not about just how quick your response times are, it's also about how many requests you're able to complete, right? The throughput, right? So because of the resolution, the graph is below. So you can see here that the one with the blue had a low throughput. It was able to, in the span of 2 minutes, it was able to serve a throughput of 45 requests per second, almost average. Whereas if I improve my scale, I am able to improve my throughput almost double, right? And obviously, if you combine this with auto scaling and other benefits that the app service comes with, you can make sure that your app is always working with reliability. Why reliability? Because I've seen incidents where app works, but the response time is so slow, up to a few minutes, that the customers are frustrated. Let's say SBI login back in some time, IRCTC back in some days, years ago, right? Wherein it is frustrating as a user to click and then wait for a long period of time, right? So again, this is an important element when you're building reliable services with Azure, right? So for the sake of this demo or workshop, this is all I have for now. And I have some links to some course, not my course, but it's basically my recording for something called as Pulumi, making sure that you are able to deploy your resources successfully. And there is a Pluralsight course to give you an insight on, rather let me take you there. The reason it's important to share is because many times it happens that you, as a developer, you start your journey writing code, slowly are introduced to different services depending upon your project. So let's say if your project is using functions, only then you are interested in using functions. Otherwise, you are not having any clue what it is, right? So the Pluralsight course I'm talking about includes key details that what are the overall services on Azure and how you can take advantage of that. Of course, this one is not exactly free, but there is, in my slide, there is another link for Microsoft Learn as well, which is like a free official resource from Microsoft, right? So what I'll do is I'll also share that with you guys via Augustine, and you guys can contact me or reach out to me by my email if you have more questions or if you have any queries. Thank you so much.